Assalamualaikum everyone. Today our group will be presenting for PHY380 in the topic of advances in ultrasonic non-destructive testing. Our group member firstly is me, Nawar Rahana binti Nizamuddin. Secondly is Sarah Emilia Farisha binti Muhammad Farid. Thirdly is Nurfani Najiyah binti Rabu. And the fourth one is Aminah Najiha binti Zulkarnain. The last one is Siti Nadia Safia binti Syekh Ibrahim. For the introduction of ultrasonic non-destructive testing is ultrasonic non-destructive testing, also known as ultrasonic NDT or simply UT, is a method of characterizing the thickness or internal structure of a test piece through the use of high-frequency sound wave. The frequencies of pitch used for ultrasonic testing are many times higher than the limit of a human hearing, most commonly in the range of 500 kHz to 20 MHz. Next is ultrasonic testing is similar to the ultrasonic principle used by an obgyn during pregnancy or nasal sonar. The ultrasonic non-destructive testing method use high-frequency sound wave travelling through a pipe to detect discontinuities. In industrial application, ultrasonic testing is widely used on metals, plastic, composites, and ceramic. The only common engineering materials that are not suitable for ultrasonic testing with conventional equipment are woods and paper products. Ultrasonic technology is also widely used in the biomedical field or diagnostic imaging and medical research.
Here the advance in ultrasonic non-destructive testing that relevant to scientific instrumentation. First, we have phase array ultrasonic testing that use multiple ultrasonic elements and electronic time delays to create a steerable and focused beam of sound wave. This offers precise control over the beam angle and focal point, enabling detailed imaging and the detection of flaws in complex geometries. Next, we have high-frequency ultrasonic testing that use higher frequency to achieve better resolution in detecting small flaws and thin materials. This provides superior defect characterization, especially useful in industry requiring high precision such as aerospace and semiconductor manufacturing. And lastly, we have automated and robotic ultrasonic testing that integrates ultrasonic sensors with automated or robotic system for scanning and inspection. This enhances consistency, repeatability, and speed of inspection, especially in hazardous or hard to reach. Here are some application concepts in ultrasonic non-destructive testing. First, we have aerospace that ensure the integrity of critical components like turbine blades and airframes. Next, we have oil and gas that monitors the condition of pipeline, tanks, and offshore structure. We also have automotive that inspect wheels, composite materials, and engine components. Fourth, the application is construction that evaluate the quality of concrete, steel, and other building materials. And lastly, we have power generation that assesses the condition of turbines, reactors, and other critical infrastructure.
Alright, here's the detailed exploration in ultrasonic non-destructive testing, or we can call as UNDT. We have the equipment and the methods. The equipment we have consists transducers, pulsar or receiver, and display devices. Transducer is the device that converts electrical signals into ultrasonic wave and vice versa. While pulsar or receiver, it generates the initial ultrasonic pulse and receives the reflected signals. Last is display devices. is the signals are displayed on devices like oscilloscope, digital flow detectors, or phase array systems, which can visualize the internal structure of the material. For the method, we have two common methods, which is pulse echo technique and through transmission. Pulse echo technique will sense out a pulse and listen for echoes from floors or boundaries. Last is through transmission. One of each side of the test specimen and the two transducers are: the sender sends the signal to the receiver. Any reduction in the sound level received indicates a defect. For the last, which is the limitations, we would say the cost, because high-end ultrasonic testing equipment such as phase array system can be expensive. The cost of training personnel and maintaining equipment can also be significant. Second one is limited defect characterization. While UNDT can detect the presence and location of flaws, characterizing the exact nature of defects, such as crack type or precise size, can be challenging. So, additional testing methods may be required for full characterization. Here, as you can see, this is example of real-world implementation of ultrasonic non-destructive testing. First, we have automotive industry. For example, quality control check in manufacturing to inspect welds and metal parts in vehicles such as engine components. This is to detect welding defects, internal cracks, and other structural imperfections. Second, railway industry to inspect the rails and wheels of trains for internal cracks and defects. This is to identify defects that could lead to rail breaks or wheel failures. The last, construction and civil engineering. For example, inspection of bridge and infrastructure to assess the integrity of bridge, buildings, and other infrastructure. This is to detect internal flaws in concrete such as voids, cracks, and delaminations.
Next, these are the potential benefits and challenges for advances in ultrasonic non-destructive testing. For the benefits, it enhances accuracy. Newer technologies offer improved signal processing algorithm and instrumentation, leading to more accurate and reliable inspection results. Next, increased speed and efficiency. Automation and robotics integration have accelerated inspection process, reducing downtime and increasing throughput in manufacturing environment. The last one is real-time monitoring. Advanced ultrasonic NDT system now offer real-time monitoring capabilities. This is critical for application requiring immediate feedback such as structural health monitoring of bridge, pipeline, and aircraft. So for the challenges, it have complexity and skill requirement. Advanced ultrasonic NDT techniques often require specialized training and expertise to operate effectively, which can pose challenges in terms of personnel requirement and training. Second, interpretation of data. Interpreting ultrasonic signal and distinguishing between relevant defects and noise can be challenging, requiring experienced inspector and sophisticated analysis technique. So the last challenge is standardization and certification, establishing standardized procedures and certification requirements for ultrasonic NDT methods across industry can be a challenge, leading to variability in inspection practices and results.
Now, let's discuss the future development and innovation in ultrasonic non-destructive testing (NDT). Initially, the first one is advanced data analytics and AI integration. Based on AI-driven predictive maintenance, enhanced AI algorithm will provide even more accurate prediction for potential failure, improving maintenance schedule, and minimize downtime. Next, deep learning models. More sophisticated machine learning models will further refine defect detection and pattern recognition, surpassing human capability. Secondly, enhanced imaging technique. In terms of higher resolution 3D imaging, continued development of high-frequency transducer and advanced imaging algorithm will provide even more detailed 3D image of internal structure. Then, real-time tomographic imaging. Innovation in tomographic imaging will allow for real cross-sectional imaging, providing instant defect characterization and material analysis. Third, automation and robotics. Based on advanced robotic system, integration of ultrasonic NDT with more sophisticated robotic system, including drones and autonomous vehicles, will automate insertion of large or hard-to-reach structure, enhancing safety and efficiency. Speaking of autonomous data collection and analysis, fully autonomous system will continuously collect and analyze data, reducing the need for manual intervention and improving overall inception process. Last but not least, Internet of Things IoT and cloud computing. In terms of IoT-enabled smart sensor, development of more advanced IoT-enabled ultrasonic sensor will facilitate real-time wireless monitoring and data transmission. As for cloud-based collaboration platform, improved cloud-based platform will enable more efficiency data storage, sharing, and collaborative analysis, allowing experts from different locations to work together seamlessly.
For the conclusion of ultrasonic non-destructive testing is, this technique is using a high-frequency sound wave to inspect materials for defects or imperfections without damaging them. UT is a volumetric method that can detect flaws inside a material, unlike surface inspection method. UT works by sending short ultrasonic pulses into a material with an ultrasonic transducer. The ultrasound reflects off defects in the material and is made visible in a graph. This graph can provide information about the depth, size, nature and orientation of the defects. UT can also be used to measure the thickness of a material, such as the wall thickness of pipes. UT has many applications throughout the industry, including well inspection, ship surveys, pipeline management, and monitoring pipework corrosion and erosion. That is all from our group. Thank you.